Corner. Once a month, we bring in a guest from the Coordinate Metrology Society to talk about metrology training, and things like that. So the Coordinate Metrology Society's conference, the CMSC, is the only show of its type in North America for portable 3D measurement hardware, software, and peripherals, focused mainly on large volume 3D measurement. CMSC Corner is our way of staying on top of the events at the Coordinate Metrology Society on a regular basis. Today, we'll be talking to John Brown of Geodetic Systems, which makes photogrammetry systems. What is photogrammetry? Well, John's going to tell us. Hi, John.
Hi.
How are you doing this morning?
Good. How are you guys doing?
All right. Well, photogrammetry, assuming people have even heard the term, might be considered old school by some, since it's really, photogrammetry's been around for a really long time. So maybe tell us a little bit, just briefly, what photogrammetry is and why it's still alive and kicking when there are a lot of other measurement technologies with lasers and blinking lights and moving arms that seem a lot sexier than photogrammetry.
Okay, well, that's a good question, and thanks you guys for having me on. It's a real pleasure. For those of you who aren't familiar with it, photogrammetry, I admit it's hard to pronounce. It stands for photographic metrology, or measurement from photographs, and it works the way your eyes do. So your eyes look at things from two different perspectives. Photogrammetry works the same way. You take pictures with a camera like this, some specialized camera that we make and modify, and you take a couple of pictures just that quickly, and you process those pictures using photogrammetry, and this results in high accuracy 3D coordinate measurements.
Okay. And how does this fit in? How does photogrammetry and, let's say, geodetic systems fit in with the overall thrust of the CMSC, which is large volume 3D measurement? I mean, where does photogrammetry fall within that niche, within that topic?
Well, let me go a little bit more on how the technology works before I go into the CMSC, because you want to get the high accuracy we do. We basically, again, explain the technology. You put on sometimes these targets. They're very easy to remove and apply. They're inexpensive, don't cost much, very easy to put on. Sometimes you need targets like these, which are for, reference points, things like that for high accuracy. And we can even measure light dots that are projected onto the object. And if you can't actually target the object, you can even use these high accuracy probes where you touch the point of interest each time and take the measurement. So there are lots of ways to do the measurements, and it's been around for a long time, longer than almost as long as photography itself, but it survives and thrives because it offers things other current measurement technologies like trackers and arms can't. And those are both great technologies, but they require rock-hard stability during the entire measurement, and photogrammetry is different. It doesn't. Photogrammetry doesn't have to be stable. You can operate from ladders, lifts, on stable platforms, and do things that you can't do with a tracker and arm. And so we kind of like to say that photogrammetry can go places where others don't dare to tread. So that's one of the differences, and sort of makes our niche. And another niche is the object itself can actually be moving. It can be deforming really rapidly, undergoing deformations, and we can take photographs to freeze that, unlike laser trackers or arms. So in fact, a good thing we like to say is a laser tracker, which is a great instrument, can measure 1 point 1,000 times a second. Photogrammetry can measure 1,000 points 1 time a second. So there's some differences there which kind of help us make our niche. And another one we found is when production downtime is critical, photogrammetry often is a very good solution, because the prep and de-prep time, the time to target and to untarget things, can be done on a non-interference basis with production. And then when you have to do the photography, which is usually the fastest part of the whole operation, you do it and it's over very, very quickly. So sometimes we may take more time overall, but the production downtime is much less, and that's often what counts. So finally, another place where we set ourselves apart from the other technologies is often when you're doing repeated measurements. So you're doing things like deformation studies or gauge R&R. What happens is now the targets become a help instead of a hindrance, because you apply them only once. Take your measurement, make your change, or observe your change, take another measurement, it's over very, very quickly. So, you know, even though maybe we're not as sexy as the other ones, Dirk. We like to think we're different, and sometimes different is a better way to do things anyhow. So
and also very often, at least when I've seen your products used, you use these very often on really large objects like ships, right, or the really big antennas that we see on communication systems. So is photogrammetry kind of one of those pieces of metrology equipment that really is ideally suited for very large objects?
No, I would say it's suited for all size objects.
Okay.
It can be measured on things as small as a bread box and as big as a football field. So it's really a matter of the more of the other things I discussed, the instability, the repeated measurements, the rapidly moving objects. So what really separates us is not so much the volume or the size as much as those other attributes I talked about. Okay. And so the nice thing about CMSC for a company like us, which is a niche sort of technology, and so we have to find our niches, and we've been really proud to be associated with CMSC. We've been with them from the beginning 30 years ago. We've been attending every year. And what it's great for is people can come and they can come to a place where they can see all the different technologies and talk about their applications and sort of compare and contrast right there. And for us, that's been especially helpful to have that particular forum because there's no other place like that for a company like us.
Okay, let's talk about the CMSC a little bit. One of the aspects, one of the important aspects of the CMSC, and something that we talk about on Quality Digest here as well, is about the skill set that's required to be a trained metrologist, the person that works all of this different type of large volume 3D measurement equipment. When I look at photogrammetry and what other people might look at and when they see it is they might just think, well, that looks pretty easy. I mean, you just run around taking pictures. I mean, how hard can that be? Do the same skill sets that might be required of other types of measurement equipment, whether it's a portable arm or a laser scanner, do those skills also come into play with something like photogrammetry?
They do, but the photography, as you said, is very easy. There's nothing much more difficult about it than this, taking it and taking pictures from different locations. And we've made it really easy because there's no focusing of this, there's no changing of the exposure. We've taken all that out of the equation, and we've made it pretty much a point-and-shoot camera. So that part is really very easy. We've also made a lot of the software development really easy. So those sort of things are easy. But as I said, the principles are different. The concepts are a little different. It's not the same as the thinking and mindset that people tend to have with trackers and arms of this is my rock. My instrument is my rock. And you have to kind of sometimes overcome those ways of thinking where people think, oh, I have to do it this way because I'm so used to this technology. So having said that, I'll say that people who have experience with laser trackers and with arms, if they've got good experience with that, it won't take them long to pick up a lot of the principles. And then also, I think, to see the benefits because they know where they can't go. And then they start to see that they can go places with us that they never could go before. Okay. So that's kind of our niche. That's how we survive. And we think we thrive. We think the exciting thing is if you look at the trend, what has happened is cameras are getting cheaper, cameras are getting higher resolution. Those are trends that we like, and we think they're going to continue going forward. So even though photogrammetry's been around for a long time, we think it's going to still be around for a long time, and we plan to be there with it.
Okay. Well, John Brown, president of Geodetic Systems Incorporated, thanks for joining us this morning. If you are interested in photogrammetry and other large volume 3D measurement technologies, you should check out this year's Coordinate Metrology Society Conference, the CMSC. CMSC 2016 will occur just outside of Nashville, Tennessee next July, and as always, Quality Digest will be there. And if you go there, you're going to see lots of great technology. You're going to see photogrammetry from GSI. You're going to see laser trackers and scanners and portable arms. Mostly all of the things you will see will be oriented towards a large volume 3D metrology. So hope to see you there. And John, thanks for joining us.
Thank you, guys, and I'll be looking for my participation trophy.
There you go, the John Brown Trophy.
Yeah, the John Brown photogrammetry trophy. Thanks.
We'll see you soon.
All right,
thanks,
bye.
John.
Good talking to you.
You too.
Bye.